Welcome back. Hope you enjoyed that set of challenges. You are now in section 2 of the planes of prototypes. And in this section, the first thing we're going to do is take a look at a second way to build objects using object.create, and it will tie in very importantly with prototypes. Using inheritance, we can create new objects with our existing objects as prototypes. So here, we're going to go ahead and set up a new object, a new shoe, and we're going to give it a size property, a gender property, as well as a construction property. If we wanted to create a new object that used shoe as a prototype, we'll create a variable called MagicShoe, and we'll use the object.create method and pass in shoe. Whatever you pass in to the create method will be the prototype for the new object. If we logged out our MagicShoe now, we would see that the object is exactly the same as the shoe object. It inherited all of its properties from shoe, just like we'd expect from a prototype. Now on this new object, we could add a few properties. Let's say jewels would be ruby. We could say travel action would be click heels. Is this sounding familiar? And then the actions required would be 3. And then we would get a ruby slipper out of it. Fantastic. If we log out the MagicShoe now, you can see that we have all of the new properties added to our object. Just to show that our original prototype object has not changed at all, we can log out shoe and we can see that everything has stayed exactly the same. Let's take a closer look at the inheritance inside of our new shoe setup. We can actually use an inherited method from the object prototype to demonstrate our newly created prototype chain. Take a look at this line of code. It says object.prototype.isPrototype of. Do you remember that property from the object prototype, isPrototype of? What it will do is look at the object on the left and see if it's a prototype of the parameter object. So in this case, we're asking, is object.prototype a prototype of shoe? Since that is true, the object prototype is in fact a prototype of shoe, we'll get a true returned from that method. Next, if we were to call shoe.isPrototype of MagicShoe, we will also get a true. That's because we used shoe as the prototype of MagicShoe. Now just to show that we don't always get true from this situation, if we called MagicShoe.isPrototype of shoe, we would see that that is false. That's because the MagicShoe is not at all the prototype of shoe. Now, what happens if we call object.prototype.isPrototype of MagicShoe? Well, you might think false because object prototype is way up there and MagicShoe is way down there. But actually this returns true, and that's because isPrototype of looks all the way upward through the entire prototype chain to see if the object that's on the left-hand side is ever a direct ancestor of the object that's passed in as a parameter. In this case, it only has to go 2 steps up to find the object prototype, and so we get a true value returned. Cool, so now what if there were other kinds of shoes? Could we use the same prototype to create boots, sneakers, sandals, or whatever that is? Well, let's check it out and see. So here's our shoe variable, right? We got a size 6, we got a gender of women, we got a construction of slipper. If we decide to make a variable called men's boot and assign to it the new object that comes out of object.create on shoe, what do we get? We get a men's boot with a size of 6, a gender of women, and a construction on slipper. That's no good. That kind of sucks. We're not really getting what we were looking for here. What can we do about that kind of situation? Well, we might build a prototype that has just empty properties, all the properties that we want that are empty. Let's see what happens when we do that. If we make our shoe variable have all those same properties, but now set all those properties to undefined, well, so now we have a prototype that's empty, but what do we do with it? Well, let's try making a men's boot variable and assigning to it the object that comes out of object.create on shoe. What we get then is just an empty shoe object, right? And then we have to assign all the properties their specific values. We'd also need to do the same thing with a variable called flip-flop. We could create a shoe an empty shoe, and then assign all of the properties. Guess what? This kind of sucks. You could see already how tedious this would be. If every time you went to create a new shoe off the generic empty shoe, you needed to put every single property in each one of those objects. That would be kind of terrible. And actually, all of that is way more code than it would take to just start out by coding an object literal and putting all the properties in on your very first object literal. So we need a different way that won't be so cumbersome and that will automate our property assignment. Let's take a look. Pretty cool. First thing we need to do, we need to determine a whole bunch of common properties of a shoe class. What's a class? It's a set of objects that all share and inherit from the same basic prototype. So size, we know that's one that shoes should have, right? All shoes have a size. How about color? Yeah, that's all shoes. Gender? Yeah. Construction? Sounds good. What about lace color? Well, some shoes don't really have laces. Look at the slipper. Or the flip-flop doesn't have any laces. So let's go ahead and put that under some shoes. How about the function lace up? Say if we had a function that laced up the shoes. Does that belong to all shoes? No, because not all shoes have laces. So we'll put that under some shoes. How about jewels? Thankfully, not all shoes have jewels. What about bow position? Well, no, I don't imagine there's many bows on work boots. What about put on? Well, yeah, we could have a function for all shoes that puts on the shoe. Dimensional travel, like say for the Ruby slippers. I'm pretty sure dimensional travel is just some shoes. Don't quote me. And takeoff. Takeoff is probably an all shoes function. Now, with a good set of these properties, we can expect all of the shoes to have. We're going to be ready now to build what's called a constructor for our class. These other ones we'd get to later. So now we will build a constructor function for our shoe object. A constructor is going to allow us to set up an inheritance as well as assign specific property values for a specific instance of the object. That's pretty cool. Looking down here, you can see we've established a function and we've called it shoe with a capital S. That's important because capitalizing a function's name sort of distinguishes it in JavaScript as a maker of an entire class of objects. Now, each of these parameters that you see here will be specific values for a specific kind of a shoe. The constructor function will construct a brand new shoe and then pass these specific parameters into that particular instance of the shoe. Now, how will it do that? How will it take the parameters of the function and put it into a new shoe object? Well, we'll use the this keyword here. And again, the this keyword is very useful. The this keyword is going to have some unique behavior inside of our function. It's automatically going to refer to the new instance of the class that is made. So when we set this.size equal to shoe size, as well as these other assignments, what's happening is the shoe constructor is building a new instance of a shoe and passing all of these parameters into that particular object from the class. We could also add some functionality here. Here's our put on and take off functions, which we've assigned as function expressions. Inside one, we've got an alert that says shoes on. And then in the takeoff function, we've got an alert that says, what's that smell? The important thing to note is that these functions will be common to all shoes everywhere. Now we got to figure out how to use the constructor to actually make the new shoe object. Well, we got a new keyword here, and it is new, in fact. What we'll do is we'll establish a new beach shoe variable, and then we'll assign to it the object that comes out of the constructor function. How do we call the constructor function? You can see there that that new keyword asks the shoe constructor to make a new instance with these particular parameters, meaning 10 and blue and women and flip-flop. If we go ahead and log out beach shoe, we can see that we get a shoe object. Notice that the front of the object, its name has changed from object to shoe. That's because we have a shoe object. And inside of it, all of the exactly correct properties that we would expect, plus some functions. If we were to now call beachshoe.putOn, we'll get a pop-up that says shoes on. That's because the putOn method is accessible to any shoe that we create at any time. We could even add properties that are more shoe specific later. For example, on a flip-flop, there's 2 straps, and we might want to add that there are 2 straps to that beach shoe. So we would say beachshoe.straps is equal to 2, and it would add it right in. But wait, hold on. Where's my efficient inheritance? Yeah, I don't see any. There's not any here. We've got an object builder, but we haven't really used the concept of JavaScript inheritance that we were promised by the constructor. So far, looks like our constructor just builds an object with a bunch of data values and a bunch of functions. In other words, all the properties that each shoe has belong to that shoe. They aren't stored somewhere else and then accessed by the shoe. That's really important. We want to make sure that we have a normal inheritance set up here so that we can have really efficient data storage. Do we see anything about our shoe that will be the same for all shoes? Let's check it out. Every single shoe is going to have those 2 functions. But why? Wouldn't it be better to have those 2 functions in one object that every shoe everywhere can access? Yes, it would. So let's try that. First thing we need to do is assign a prototype to a constructor. That's right, a constructor is not a prototype, right? Constructor is just a function, and a constructor has a prototype. So by setting a constructor's prototype property, every new instance that we ever make, every time we instantiate an object, it will refer to that new prototype we've made for all these cool extra properties. So here, with our shoe.prototype, we're going to go ahead and build a new secret object within the constructor function's prototype property. This will tell every created shoe to inherit from that object. You might notice something else here. We haven't drawn attention to it yet, but every time we've called any prototype at all, be it array prototype, string prototype, or the object prototype, we have always called it as a property of a certain class's constructor function using the dot operator. That's no different here. We got the shoe.prototype ready to roll. Inside our prototype, we're going to build 2 properties, put on and take off. Notice they take a property style now. To put some values in those particular properties, we'll just build some anonymous function expressions that alert our desired messages. Notice now that our shoe constructor gets considerably smaller, and that means that every object we instantiate, every shoe we make, will also be smaller. That saves a lot of data, especially if you're running a shoe store, right? By putting both of those functions in the shoe prototype, we force every shoe object to inherit those functions when it needs them. So let's come back to our beach shoe variable. We're going to create it the same way. And if this time we were to console.log beachshoe.gender, what happens is beachshoe just looks directly within itself for the gender property, finds it, and logs it out, and we get women. But then what happens when we do beachshoe.takeoff? Well, that's a method that beachshoe does not find in itself. So what it does is it looks up to its prototype. What is its prototype? Well, that would be shoe.prototype. So it looks up there and it says, hey, shoe prototype, do you have the takeoff method? Shoe prototype nods and says, yes, I do, and you may use it. As a result, we get the alert message, what's that smell? If we were to call beachshoe.hasOwnProperty on the string construction, well, neither beachshoe nor the shoe prototype own that property, hasOwnProperty. So what happens is we go up even another step back to the object prototype to find the hasOwnProperty method, and there it is. And the object prototype says, yes, beachshoe, you may use this property. Here you go. But then what happens? The hasOwnProperty function now looks to see if beachshoe itself has the property construction, which it does. And so we get a true value out of that line of code. Now here's something very useful. prototypes can actually refer back to their instances to pick up some data. Let's see about modifying our message functions with some of the data in our shoe objects. So let's go ahead and get rid of our current alert messages. So now in our new function, we'll say your whatever style the shoe is on. Inside the takeoff function, now our alert message will say, phew, somebody's size, and whatever the size is, are fragrant. What's important here is that the this keyword will look back down to the particular shoe instance that called the function and pull all of the property data from it. So if we call now beachshoe.putOn, we'll get your flip-flops on instead of just your shoes on. And if we call beachshoe.takeoff, we'll get phew, somebody's size 10s are fragrant. And now you have a few more very useful skills with prototypes, and we will release you to a few more challenges to see how you do there. We'll see you back in the next section.